Okay, thanks everyone for going down. So my name is Matt Hamilton. I'm an engineer here at Compose. So for the students here, you may have heard there's Compose and Cloudant, which are two kind of divisions of IBM here, or two parts of IBM that are both involved with cloud-based databases. I'm actually a graduate at the University of Bristol Computer Science School myself, so I was there sort of 22 years ago. Today I'm going to be talking about a concept of monetizing APIs and using a particular protocol called Interledger and a part of that protocol called Interledger Stream. So I'm going to talk about why you want to do this potentially, talk a little bit about how it might relate to what we do at Cloud and Compose, and a bit about how it might relate to the kind of the general wider world and what the issue is. So, Interledger, into what? So you've probably heard of ledgers, distributed ledgers or blockchains. Blockchains are a distributed type of ledger, but ledgers can go right the way back to basically books, paper with numbers written down, and somebody keeping a tally of how much people owe. I'm going to need to sit on that later maybe, but no, that's all right, don't worry, fine. So the idea behind Interledger is a protocol that allows secure payment across different ledgers. So you have the internet, which is allowing traffic to flow between different networks. Interledger allows value to flow between different ledgers. So the idea being is that there's not going to be sort of one true ledger or one true blockchain, despite what Bitcoin people might tell you. It's not going to necessarily take over the world. There's many different types of blockchain out there. IBM are involved with several different ones. There's lots of different ones out there with different sort of systems, and there's the whole legacy financial banking system. So this protocol Interledger was created, and it's now actually part of the W3C, the World Wide Web Consortium, that ratify a number of standards, including all the things between basically your browser and a web server, everything like HTTP, the protocol, and a lot of other protocols as well used. And Interledger has a stack of protocols, kind of similar to if you've seen the OSI layer of network stack, in which you've got the sort of the physical stuff at the bottom, cables and Wi-Fi, and that working your way up to different layers. You've got TCP, or your IP, and then you've got TCP, and then you've got, say, whatever, HTTP, your web protocol on top of it. Interledger takes a similar model, and you have various layers, a bidirectional transport layer, the Interledger version 4 protocol, and Stream on top, which is the bit that we're going to be talking about. So as I mentioned, what Interledger allows you to do is to send value from one type of ledger to another. So say I owe you some money, I owe Manuel, £10 for lunch or something like that. The first thing I've got to find out is, how do I pay it to him? And he might say to me, well, I want to use PayPal and send it to my PayPal account, or here's my bank account, or I use Monzo and there's a nice link you could send it to me, or I want it in Bitcoin, or whatever it might be, or euros. We've got to somehow negotiate how I transfer this value to him and what denomination it is in, whether there's any conversion factor. So, if I owe him £10 but he wants it in euros, I've got to work out what that is. Or if he wants £10 and I've only got euros, or I've got whatever Mexican peso or something, Thai baht, how do I pay him? And so Interledger takes care of all of this with a number of plugins that allow these different ledgers to connect and form a network in which value can move from one network to another through connectors. And these connectors can do things like exchange rates, as stuff goes through, or conversion from one currency to another. So the ultimate goal with Interledger is that I should be able to pay Manuel some value, and I don't need to know what network he's on, how he wants it. He just says, send it to me. In the same way you'd say, send me an email, and my email address is Manuel at whatever. He would say, send it £10 to me, and my Interledger, what's called payment pointer, is Manuel at blah, blah, blah. I send it to him, and it doesn't matter what I send it in or what he wants to receive it in. the network will convert it and route through various hops to get there, right? All securely, all as an atomic transaction. If any part of it fails, it all rolls back. You don't end up with stuff stuck in the middle. You don't have to trust random entities in the middle not to steal your money. So the idea being is you're going to end up with this network and what has been termed the Internet of Value. And the idea being that at the moment we can send data easily around, but we still can't send money easily around. If I want to send some money to Australia, still the quickest way is literally go to the cash machine, get it out, put it in a suitcase, get on a flight and fly to Sydney. I will get there before an international wire transfer will, which is just absolutely ridiculous in this day and age that money takes that long to move around. So that's the idea of the Internet of Value, the idea of being able to move value around as easily as we can move information. So what's that all got to do with monetizing APIs and maybe some of the stuff we do at Cloud and Compose? Well, some of this stuff that the Web Payments Working Group in the top left have been working on, they're a group within the W3C, a working group that have been working on how do we fix payments on the web. Because they've historically been a problem. Whenever you go to a website, you want to buy something, you have to enter in your credit card details, or you have to pass through something like PayPal, or a lot of us, I know that I certainly would just say, well, I'll just use Amazon because it's got my details. I don't care maybe if it's a little bit more expensive than that one or whatever, but they've got all my details, that's easy. The Web Payments Working Group are working on several standards to help fix that. So standards within the browser, one particular one called the Web Payment Request API, and another one called the Payment Handler API. So currently, every person that designs a website, any kind of e-commerce process, has to build in a form that takes in a credit card number and takes in an expiry date and whatever, and passes those to a processing company. They have to deal with the security of that, or they have to delegate it just to the processing company to deal with. The idea behind the Payment Request API is you'd be able to put in, effectively, an HTML tag that says, give me this amount of money. I don't care how, just give it to me, somehow send it to here. And your browser will then take care of that. And your browser will then use the Payment Handler API to negotiate with some other piece of software you might have locally. So you might have some sort of wallet software running on your computer or on your phone. Maybe it's then connected in with something like Apple Pay on your phone or Android Pay. It can then take the payment and securely route it to the website, so that the person designing the website doesn't have to get involved in the actual mechanics of how does this value move. And this is all being already built into a lot of browsers. So in the bottom left of the screen here, very small, you can't really see, but is a matrix of a number of browsers. So Firefox, Chrome, Safari, they're all supporting it to a greater or lesser extent. Internet Explorer, Edge as well. And there's various kind of concepts here. So this is one from MasterCard, kind of showing how it could work using these standards. The whole idea is open standards. That's what the W3C is all about. The idea is that we should be able to plug in any kind of system for storing your payment at one end, and somebody who wants payment, and all the bits in the middle are kind of negotiated automatically. So the bit I'm kind of going to mainly sort of show you today is a part of the protocol called Stream. And Stream is a way of multiplexing money and data over the same connection. So imagine you created some sort of service in which you had a business in which maybe, I don't know, somebody paid you money and you would store their data. Maybe, a big base of data, say, that somebody would send you data, you would store it, and they could query it and then get it back again. Really clever idea. They need an account. They need to pay you somehow. So somehow they need to pay you for that service. And that's a completely out-of-band process that involves invoices or credit cards or whatever it might be to deal with that. What if the payment can actually come over the wire with the data? So you say, store this data, and at the same time, multiplexed in with that data is, here is some money at the same time. Now, that's now possible because of things like cryptocurrencies, which enable us to be able to represent some value in some token that can be transmitted electronically along with the data. So Stream is a protocol for dealing with that, for multiplexing the payment and the data together. And it deals with a lot of the intricacies of maybe breaking payments up into smaller payments so they get sent, and different gateways might be able to have different liquidities, and so they might have different amounts that they can take at any one time, in the same way that when you send a packet of data on the internet, well, a stream of data is then broken up into packets. Those packets might be broken up further, but depending on routers, or reassembled, and they get to the other end. Stream does that same kind of thing for payment. So that's kind of where it fits within. If you look at the Interledger architecture, it's what they would sort of call layer 4, the transport layer Stream. Below that, you've got various bits of Interledger underneath. And then right down the bottom, you've got things like blockchains and central bank ledgers and things like that that actually store the value. So I'm going to show you a quick demo of how this could work. And like I said, this idea of being able to send payment and data at the same time. So just to give you a quick architectural diagram that will hopefully make the rest of it a bit easier to understand. We've got a client, we've got a server. Client is my laptop, the server is a machine hosted somewhere else. Now, on the server, I've written a small little API that I'll show you, that is just a little server written in Node.js, and there's just a little hello world server in there, a few lines of code to return hello world. On the client, you're probably familiar with the tool Coil, is a tool on Unix systems for fetching requests, HTTP requests, and so databases like Cloudant you can interact with directly with Coil. You can say get this data or put this data into Cloudant. And we've got a variant called ILP Curl that works with Interledger. So ILP Curl connects to a thing called MoneyD, which is a daemon running locally. That can then use a plugin depending upon what the underlying kind of payment architecture is. So in this case, we're using one called XRP Uplink plugin to a thing called the XRP Ledger. XRP is a cryptocurrency, a bit like Bitcoin or Ethereum, but a lot faster and cheaper for smaller payments. And on server, we've got a similar kind of stack as well with MoneyD, this Uplink plugin connected in.
So just these systems you've got running in the proof of concept, is it? Or these?
It runs. It's commercial. So yeah. Like I said, I'll show you an example of it, just a sort of Mickey Mouse example that I've set up. But I'll show you, sort of talk about some of the places where it's actually being used kind of in production now as well. Not within IBM, but outside. But it's, like I said, we deal with databases here at Cloud and Compose, and it could be something that could happen, that you could have a service in which you could pay directly as you send the data. Because if you think about it, a lot of the times when you sign up for a service, you have to provide a username and a password, normally just to protect the credit card details you're sending, and then you have to put in all the payment details of credit cards. Well, if you didn't have to send all the credit card information sort of manually, and it was taken care of, sent in line with the data, then you wouldn't actually need the account in the first place. You wouldn't even need to sign up. You would just go to the service and go, here's data, here's payment. And the service goes, right, fine, I've got payment, you paid, fine, I'll do what you want with the data. And that's it. You don't need to sort of pre-establish some kind of relationship or account beforehand. And a server could pay another service. So, you could upload it to one service, and that service could then say, well, we need to do some machine learning on this data, and so we need to send it to some machine learning model somewhere, and it can then pass on some of that payment, and one service could pay another service for doing things. So I'm going to show demo gods willing. So I have here, that's locally. This is the server, and okay. So let's start with. I will try and make it. I've made it bigger. I'll try and make it even bigger for you.
Oh, I suppose getting that.
How's that? Is that big enough? Almost.
That's better.
That's better. Move closer. Okay. Starting at the top, this is Node.js, JavaScript. So starting at the top, we're just importing a number of libraries and plugins. We're using a framework called Coil, which is just a library for allowing you to write simple API, web-based API services fairly easily. And let me just simplify this actually. There we go, that's the simpler one. This is the Hello World version, right? So we've got a number of imports there, and then actually it gets really quite simple. What we do is we set up what's called a router, and we say, when you get the root URL, so just slash, we use this piece of middleware called ilp.paid, and they have to have paid, so the price is 1,000, what are called drops. In this case, a drop is 1,000,000th of an XRP. One XRP is about 25 pence, 20 pence, something like that. So we're talking, 10,000, 100,000th of a pence or something like that at the moment. So a very, very, very small amount, and it will return hello world. And then at the bottom here, we're basically just saying, start the app up, use this particular router, and listen on a particular port, right? So the only bit in here that is actually ILP specific is that, besides some of the imports, is this bit here, in which I basically say you need to have paid that. That's the only bit that I've basically added in from just being a bog standard Hello World app. So I can start. What I have to do first of all is start. There was the MoneyDemon. Which starts, so I'm going to start that MoneyDemon running. You don't really need to be able to necessarily see what all of that is doing, but got that. And then I'm going to start our service up there, Hello World, and on the client. I have to start MoneyDemon on here as well.
I can see MoneyD.
You can see MoneyD, good. I thought that was quite a nice little thing they did there with that, or MoneyD. Now, what I mentioned is this: you're using a plugin to a particular ledger called the Interledger, called the XRP Ledger, and we've got a couple of accounts. I've got a couple of accounts running there, and this is a site that just allows you to kind of browse transactions on those accounts on this distributed ledger, this blockchain. And one of the things you'll see down here, is a transaction to create what's called a payment channel.
This is XRP specific, sorry.
Yeah. This,
XRP specific, and it just shows you all transactions that are happening.
all transactions are happening on the ledger, yeah.
On a particular ledger, or is this across all of the XRP?
This is the whole XRP network, so it's a public ledger that anybody can use, and this is an account on here that I've got on here, and so I'm looking at my kind of XRP wallet and showing the transactions. And so the first one is this payment channel. Well, actually, it's the payment channel create here that gets created, and that creates this payment channel that allows the value to flow. So this is just to basically show you this is real and happening on a public ledger. This is not some sleight of hand between the two services. That's going on there. So MoneyD started there. Our node thing started there. So I should now be able to say. Make that bigger as well for the side at the back. I should be able to say ILP curl, give it the name, and it should go and fetch it, and we get back hello world. Now you might think, okay, well, so what? Well, what you don't see, because it's all behind the scenes very clever, is that it actually sent payment in there as well. So that sent 1,000 drops, and I can possibly show that on this here is a GUI for that MoneyD app, that's the daemon that's running, and here we have this balance that shows here, and we've got a parent account and a local account, and they will be reconciled every so often. So what happens is, it's not, whilst I'm saying it's sending it live, what it's doing is it is sending with the HTTP request effectively a claim for a certain amount of money. and then every so often those claims are batched together and then cleared. But these are cryptographic claims that are sort of, because we've opened that payment channel on the ledger, they're good. You can't sort of renege on them, so to speak. Yeah.
Can you hit it with normal curl so we can see it fail without it?
Yeah. Actually, that'll be interesting. Okay. I was going to show you what happens if I don't give it enough payment, but let's see what happens if I try this then. No valid payment token provided. So standard curl, good one. That's nice. Yeah, I hadn't thought of that. Yeah. My glamorous assistant. I can specify how much I want to pay it. So if I can say the maximum I want to pay is 100 drops, it'll come back with an error and say the source amount exceeds. It's a pretty cryptic error that's come back from ILP Coil, but it basically says you've not paid enough, right? If I pay 999, again, it'll come back, say I can't do that. If I say 1,000, then it works, okay? And we can see, if I go back to this GUI, if I refresh this, so we saw that 9999900, they're actually taking 1,000 off. If I refresh that, that should be a little bit lower now. Because it's gone through again, so there's another 1,000 that's come off of there. So the parent balance is down 2,000 and our local balance is up 2,000, and that will then be claimed. So when I showed you this this ledger here, every so often there'll be these payment channel claims that come through, and so that's basically reconciling. So when it reaches a certain time or a certain amount, that claim will be done by MoneyD to basically actually settle up that payment.
How do you know that you've already got access to the service, right? How do you know that settling, the claim has been settled, there's enough money in the account to...
So when I open the, when this payment channel create occurs, it basically reserves a certain amount of money. So in that case, it reserved, I think, probably 10 XRP to use. It's saying here, I can't remember if it says in here or not.
Right, so you reserve, so the XRP knows how many drops or whatever.
Yeah.
So when your client says, says, pay this someone 10, whatever, 1,000 drops,
Yeah.
It gets sent. The ledger knows it's got enough clear money to do it,
Yeah.
and it's kind of like, when the settling happening, it's basically like an escrow sort of
Yes.
things, and it's just going to settle them at some point in time.
Exactly. So it's like an escrow, and what's happened is that the MoneyD at each end has basically entered into a contract, actually not directly with each other because they're going via this ILP network, and there's actually several hops in between. But they've both connected to an intermediary, and they have created this effectively escrow on both sides, and so they both know that they're good for the money, and then it goes through. I'm glossing over a little bit of the detail here, but there's a whole process of cryptographic locks that go on to basically ensure that you can't renege on the money, basically, that goes through.
What happens if you're showing happens if you underpay? What if you accidentally mistype the number and overpay? Does it actually pay that much? Or?
No, that's the maximum you're willing to pay.
Yes. Okay.
So it negotiates with the. Was it there? Where was the? Where have I not got it on here? Oh, that's it, 'cause I'm on the client. It's the server I need to do it on. There we go. Sorry, he's finding the right... so stop that. There we go. So in the server side, I said you have to specify, you have to pay 1,000 drops to access this URL.
Okay.
Right? And so it negotiates with them and it checks to make sure, okay, you've got 1,000, yeah, I want 1,000, yeah, let's go for it.
So
what if you send like 2,000?
Yeah, that's what I was meaning.
So in that, I don't, this is the maximum that you're willing to spend. So Money and ILP actually negotiate the correct amount. You could possibly go lower down within the stack and maybe try and oversend.
Yeah.
I'm not entirely sure what would happen at that point. So let's make this a little bit more interesting. We had Hello World. What if we created a service that could return some random data? So I'm going to create a service, and I've got some really high quality random number generator, and it's so good, so high quality, so random that you're going to want to pay me money to use it, right? So I'm going to create this service, and it's going to cost 20 drops per random byte. So you can ask for as much random data as you want, and you basically pay for as much as you require. We've got a function here that can work out how much the total is, and we have this new endpoint here, random on here, and we say ILP paid, and rather than give it an actual amount, we've given it a function here, and we will return actually some random bytes based upon the size that we ask for. So what I should be able to do now is start this up. And I should be able to connect to it here and say random. I'll give back some random. Right, so those are some random bytes. Someone give me the name of something that can, what can get random stuff out to hexascii? No. Hexsum. There we go. That's a bit easier to see then. Okay, so that's returning back some random data every time, and every time I do that, I'm basically paying for that random data. But I can actually say, I actually want. Oh, size wrong. I actually say I want kilobytes worth, and it'll fetch that. And so it is paying then based upon how much I'm asking for. So it is literally pay as you go service on there. Like I said, that's one example. That's sending payment along with the request. So the actual payment claim is going alongside the HTTP data. And as you can see, I made very little change to actually get that to work. And if I had a little bit more time, I was going to try and set it up actually as a proxy to a Cloudant server and then run it. It would be great if there's something like a sort of a mod proxy or Nginx type plugin. I'm sure somebody's written one that can sit in front of any other service and basically just demand money for traffic coming through. See. People have done all sorts of fun things with it. Quake Deathmatch using it as well, so it streams payment as you're playing, and every time you kill somebody you get something, every time you get killed it takes money off you. Things like that. There is, back to here, boom. There's a service called Coil. This is just the corner of my blog here, and down the bottom you might be able to see there's a little ticker down the bottom counting up money. Basically, there's a service called Coil that will pay people, content creators, as somebody's browsing their site or say watching something on YouTube, whatever. So to kind of deal with the current broken model of advertising and paying for advertising as a way to fund content creation. So the idea with this is that it's actually, you are actually paying for content directly, but your browser is streaming it without you even really knowing about it. You go to the site and it starts streaming the data. If we go to, you might have noticed, so down the bottom here of this site, it's there's a little number counting up down the bottom there. So my web browser is actually currently live streaming payment to the owner of this blockchain explorer, and that's how they fund the development of the site. So, you know, whilst we've been on here, it's sent one US cent basically, but obviously that adds up over time. The idea being, up until now, there's not really been an efficient way to make really small, micropayments, but this allows you to to do it and to actually stream it.
If you go and make your own blog, will you pay yourself?
Yeah, probably. Yeah, it might do. I don't think I'd get a huge amount necessarily doing that, but yeah, probably would do.
You accidentally go on the dodgy website or something,
Yeah.
unless you're at home somewhere, or the text will just take you what's in your money.
Good question. Well, possibly you would notice that the little plug-in there is paying. Now, in this case, this is using this service called Coil, and Coil basically add a sort of an extra layer on what I've just described, which is an all-you-can-eat business model. So the idea with Coil is I pay Coil a flat $5 a month, and they, on my behalf, when I go to a site, will be streaming payments to the owner. So it's my browser's instructing this live streaming to go on, but I don't have to set up MoneyD and all of that kind of stuff that I showed you to do that. All I do is I just hand over a credit card, but I get a kind of an all-you-can-eat buffet of data there. So in that case, I don't have to worry because it's their business model, not mine, that's dealing with that. Yes, with something like this, you would see it sort of counting up there, and it's it's your browser that's sending it. So it's up, you'd be able to say, okay, don't send more than this amount. Or only send it to these sites or whatever. It's entirely coming from your browser, so it's within your control. There's actually no sort of middleman in the middle there. The payment is going directly from one to another. So, yeah. Any other questions? Cool. Yeah.
Going with the random data that you specify a size,
Yeah.
and then the price was calculated on that size.
Yeah.
Can you do it in reverse as well, in the sense of if you ask for, say, a picture, but you don't know what size it is, but the server knows what size it is, so it changes the price? I guess it just sends a different price back in the negotiation?
Yeah, so I mean, in this case, it is the server that's deciding how much you're paying. You're saying how much data you want.
Right.
The server is the one that's saying, okay, it's going to cost this amount of money. So it could be if it was I want to download this image, and it works out, okay, how many pixels are the image, and it's X amount per pixel or whatever. And so yeah, it could do the same thing. There is like as part of the HTTP verbs, one of them is dealing with options. So the options verb, you can actually, I think there's a bit of a pre-negotiation you can effectively do to find out how much would this be before I start doing it, so that you can actually determine whether or not you want to go ahead.
How widespread
It's not that. It's a weird one. It's not that widespread at the moment. So I mentioned this company Coil that are doing stuff for content creators. Coil actually went sort of live with the latest version of their offering actually yesterday. You can think of Coil as a bit like somebody like Medium, as a blogging platform, but with the ability to do monetization built in to that. So they kind of, again, they wrap it and make it even sort of friendlier. But underneath, it's ILP that's doing all the payment. Coil paid in the last 12 months, even though they hadn't even fully launched. They were just doing they hadn't launched their content creation platform. They had the payment thing. So the fact that I've got it embedded in my blog, for instance, that's been working for the past 12 months. They made 6 billion payments in the last 12 months. Tiny little micropayments, but 6 billion of them. It's almost impossible to try and work out what that really means because they're so small, and they're 6 billion could be done in an hour or it could be done in a year. It's hard to really kind of grasp the scale of the numbers. As I said, a lot of the technology is being built by the W3C working groups now and is already embedded in most of the major browsers. So it's kind of, I think the adoption is going to ramp up pretty big soon, I think, because all of the pieces are in there. You always used to have this sort of chicken and egg problem of, well, I don't have the tools to send the money, well, nobody's wanting the money kind of thing. And hopefully that's going to go further now. So the answer, not that widely adopted yet, but you saw how easy it was to do it with an API. We could sit down and get cloud and, to be able to pay cloud in the matter of a day doing this kind of thing. So, it's there's certainly interesting stuff. And there's a lot of other kind of random scenarios. Think about, you get off the airplane in some other country, you get your phone out and goes, Wi-Fi, €6 for 24 hours or whatever it might be, or, so many yen or something. Well, imagine if your phone just goes, Wi-Fi, great, yeah, I'll start paying. And you've said, well, okay, I'm willing to pay a maximum of a certain amount of pence per amount of data, and it kind of negotiates and starts paying directly. You don't have to sign up. Again, you don't need a username and password because there's no account, because you're paying directly. So I think there's some really interesting stuff that's going to start to come out of it, especially when you take into account the privacy issues, because this means you can just pay. You don't need an account. You don't need to track somebody. So you don't need the privacy issue. You kind of miss out the privacy aspect of I've had to give over some information in order to verify myself in order to pay. I've just given you that. Yeah.
So that kind of sounds like you're going to be paying something without knowing.
Yeah, potentially, which kind of goes on slightly what he was saying there about yes, you could end up paying for stuff without knowing. It's then going to, I think, be up to the client to kind of rate limit that. I mean, you could kind of say at the moment, well, look at your data access. Are you paying for stuff without knowing? I mean, I went away camping. I took my IBM laptop with me, and it connected to the backup service and backed up everything over my 3G connection. Killed my data allowance in about half an hour. I didn't even realise it was even shut, the damn thing. It woke up from sleep to back up and connected to my phone and used all my data. So yeah, there's issues, but the point being is, because it's being sent by the client, you're in control of it. So it's up to those kind of controls to then be sort of created.
So when we were on that sort of blog earlier, and we had the Coil widget
Yeah.
at the bottom, and the number was sort of going up
Yeah.
one by one.
Yeah.
So is it one unit of currency per transaction, or is it kind of doing it in bulk? My question really going towards, doesn't that limit the scalability perhaps if we're doing so many transactions in one day?
So that, in a way, is partly what the stream protocol does, is it breaks it up. You say, I want to pay this amount, so I want to pay 1,000 drops, and stream will break it up and say, well, I can send 10 drops now, and I'll send another 10 drops a millisecond later, I'll send another 10 drops a millisecond after that. And so that's up to the stream protocol to deal with that side of things. In terms of throughput, because it's point to point, there's not like a central bottleneck at all. You're just going directly between the client and the server directly there. And again, I'm not entirely sure how Stream handles that, but I'm guessing they could say, okay, well, we'll send fewer larger payments or a larger number of smaller payments, depending upon what the conditions, whether it's the bandwidth conditions or what the server negotiates. I'm not entirely sure that bit, but I know that's part of what the Stream protocol does. So. No? Okay, well, thank you very much.